Okay, so we started our review for the test, which is tomorrow, with a linear regression. This gets typed into the calculator under Stat Edit to put this in. And this is our L1 and this is our L2. And then after that's in, we go to Stat Calculate Linear Regression. Using L1 and L2 is where you draw the data from. And then you get this equation, y equals, and it usually says ax plus b at the top, and then it tells you what a is. If they tell you to round to the 100th place, do you know where that is? Think for yourself. Would you have known? That's 2 decimal places. Haven, what did you get for your A then?
9.5.
All right. And if you go with also 2 decimal places, Asher, what did you get for the B?
I got 1.5.
Then tell me if this matches up with your reality. 9.5x plus 1.5. Raise your hand if you had the same thing. Okay, cool. Then we can use that by putting the 55 in for the M, but I have an I have an X and a Y. I don't have an M. That makes you think. You go, okay, M was this one, which is the L2s. So it's like I gave you a Y value because M is like the L2, that's like the Y. So then the 55 went here. 9.5x plus 1.5. You would subtract 1.5 from both sides and then divide by 9.5. And that, you can't do it in my head. Sam, what did you get?
5.63.
Anybody verify 5.6-ish? All right, good. All right. Then that is the end of our linear regression talk. If you need a video on it, that was the other day. It's one of the videos has the word linear regression in the title for the lesson for that day. Next, let's get to finding complete the square. X squared plus 8x minus 3. Would you agree that that does not factor? And even if it did, factoring would tell you the x-intercepts, but it wouldn't tell you the vertex. The vertex is best found 2 different ways, but one of the ways we can make you use is complete the square. Everybody do the complete the square method. Start by moving this over. And then you have room to do complete the square. All right, Haven, what's the secret recipe for finding this number at the end of the brackets there?
Half a square.
Yep, half of 8 is 4. 4 squared is 16, plus 16 minus 16. And then this part factors to x plus 4, quantity squared. And then this and this together can make negative 19. And then what's the vertex? Negative 4, negative 19. Did that feel easy? Okay. Is there any part that's not making sense to you? Yes?
Oh, what's the really difficult one where it changes outside number?
Okay, that's if there's a number in front of the whole thing. And the number in front of the whole thing would have to get factored out. Okay, so let's do one of those. Y equals 3x squared plus, let me think. I'm going to make it work nice. 6x plus 1 on purpose doesn't have a 3 in it. You don't have to be able to factor it out of the 1. Go ahead and give this one a shot. And yes, this is a type of question we could ask you to complete the square on this. Don't forget the 3 gets factored out first, but obviously not from the 1. All right, I'll pause for a second while you work that one through. All right, I'm ready. So we take the 3 out. What do we have on the inside after we take the 3 out? X squared plus 2x. And again, we weirdly didn't factor out the x, even though we could have. So this is definitely unusual factoring. Okay, but we do that on purpose so that we can then do half and square. Annie, can you take it over from there?
And then you get x squared plus 2x.
So half of that is 1, 1 squared is 1. And then what?
And then you have to subtract that 3.
Ooh, wait a minute. Why isn't it minus 1 right there?
Since it's within the parentheses.
This 3 is going to scale that 1 up to where 3. So we got to multiply this one by 3 also. A lot of people will have forgotten that right there. Okay, now we have 3 parentheses x plus 1 quantity squared, because that's what this factors to. And then negative 3 plus 1 makes minus 2. And there is my new vertex, negative 1 comma negative 2. And all it would take to lose points would be to forget that this was a negative 1 and not a positive 1, because you don't trust the inside. All right, so this part right here was the trickiest part, in my opinion, is remembering to multiply that by 3, because this and this have a value of 3 and the other is supposed to counteract it. Okay, good. Next thing I want to practice with you, I'm going to pause for a second. but it's a good start. I know that in the classroom, the monitor just died, so I'm gonna fix it here. There we go. So if I flip it over, that was a good start. But then I also have to make it negative. If I make the top and the bottom negative, do you get I'm not actually making it the opposite of what it was? If I had the number 5/3 and I make the top and the bottom negative, do you get I really didn't change it at all? This freaks a lot of people out. They think you should change the top and the bottom, but you just change the top to be negative and you've got it. All right, so that is the slope, and then the rest of it can be absolutely the same. Y plus 3 equals, notice I change the two negatives to a positive, x minus 5. There's an equation that is perpendicular to the other one and goes through the same point. Okay. Next up, remember the tennis ball lab? Remember me saying that it would be smart to do that like this weekend or maybe even tonight because it would help you prepare for the test, because there's something on the test that's kind of like the tennis ball lab. So if you're going to have to invest an hour in doing the tennis ball lab, might as well do it tonight. Still strongly recommend that. So let's take a second and talk about tennis ball lab. Can you write me an equation that involves these three things? The velocity, hopefully you know where to put that. If you don't, I'll show you in a minute, is going to be 9 meters per second. Now, I know we don't know that in the tennis ball lab. That's the hard part. Gravitational constant, we'll say we're on Earth, so we're going to use the negative 4.9 at the beginning of the equation. And last but not least, our starting height, our height sub zero, is 1 meter. I know that's different than the tennis ball lab, but I don't want it to always be 2. Okay, so can you write me the equation for that? And then after you write me the equation for the quadratic that we have that matches these three things, I'd like you to tell me where is the ball at time equals 1? What's the height when time is 1? Pause for a sec. Okay, so I would have written negative 4.9. I can say x squared, or I could have said t squared, either way. My velocity was 9, so that goes there, x. And then my starting height was 1, so plus 1. That makes sense to you so far? Good. Then, what's that thing that's going to tell me this? Is it negative b over 2a? What would negative b over 2a done? What would that have done?
Give you the x.
That'd be the x of the vertex, which would be the time of the vertex, which would be the time that the ball reached the highest point. Do you see how that could be a question we could ask you? Okay. But I didn't ask you that. I asked you, what if time was 1? Well, and that's pretty easy. It just goes right there and right there. Okay, so then this part becomes negative 4.9, and that becomes 9. So y equals negative 4.9. And again, 1 squared is just times 1, plus 9 times 1, which is just 9, plus 1. And that's 10, so then it's positive, 5.1, I think? Raise your hand if you had 5.1. Cool, what is that? Like the number of bananas we get per tree? Oh. It's 5.1 meters, good. What? Meters what? Not square meters, just what is the 5.1 meters? What is it? How wide the ball was? That's the height off the ground at 1 second. Very good. It's just important to have context for what are we finding? What is this 5.1? It's 5 meters, about 15 feet, if we're going to change it into feet, off the ground at 1 second. Do we know if the ball's still on the way up or not? Think about it. Would you agree that the ball follows a course that goes like that? Do we know for sure that at time 1 that it was on the way up? No. At time 1, it already might have been on the way back down again. Could have been there, or it could have been here. How could I figure that out? I could go, yeah, that's true. I could figure out the vertex and see if the time happened after the vertex time. That's a good point. Or I could have said, what if the height was 5.1? Then it would have been y is 5.1, and I could solve my equation for that and find the 2 times. Wait a minute. Let me make sure I'm doing that right. Yeah, that's the height of 5.1. I could have found the 2 times that happened, one of which is 1. It's probably on the way up, but I don't know for sure. Okay, enough about that. And you will have a bunch of time to work after this where we've got some practice problems and a key for the practice problems. And you can always come up and ask me one-on-one help. But if I give you this equation, I'm on purpose putting an annoying variable there. And then I want to know, what's the vertex now? We just discussed what that right formula is. And your answer will have an M in it. If it wasn't for the M, you could have found me all the exact answers if I would have put a number where the M was. You could have found the vertex pretty easy. You could have found me the x-intercept and the y-intercept. But because I threw an M in there, it's going to make it more challenging. So that's what pre-calc does, especially honors. I'm going to give you a little time here. Okay, let's see how you do. The vertex. I hope you just have this memorized. Negative b over 2a, comma, f of negative b over 2a. So if you figure out negative b over 2a, you could stick it in the function. All right, so what is negative b over 2a in this case? Annie?
I have negative 1 around.
Okay, so walk me through, what's the negative b?
So the negative b is 2, 2 is the negative 2.
Okay, so negative 2 over
2a, and then a is m.
Very good. It'd be nice if they use the same letter there as, A, B, and C, those letters, but sometimes they don't on purpose so that you have to change variables. The ACT really loves to do that too. They'll put in, where you're expecting A, B, and C, they'll put in R, F, and P or something like that. So you can deal with the changing of those. Okay, so there's my vertex. Wait a minute. No, that's the X of the vertex. Nolan, can you tell me what to do to figure out the Y of the vertex? Put that where? Where do I put that? And all the X's. You are correct. So then it'd be M times. Now, can those 2 on the top and the 2 on the bottom, can those cancel? Yes, they can. Can you tell me what it is after I cancel those, Nolan? Maybe you didn't cancel those. Oh, what did you put? Negative 1 over m is correct. Negative 1 over m squared plus 2 times negative 1 over m plus 3. I know it's hard to read, but negative 1 over m is better than negative 2 over 2m because the 2's are canceled. Now that, I'll highlight in blue, all of this right here, that would be your y of the vertex. And I know that's really messy, and would you have to be able to multiply that out and simplify things? Absolutely. We're not going to take the time to do it right this second, but you'd have to be able to oh, there's an m on the top here. See how there's an m here? And there's an m times, wait a minute, what's on the bottom there? 1 over m. Yeah, there's an m here, but it is getting squared. So anyway, you'd have an m squared on the bottom and an m on the top, and so some of that could cancel. All right, let's move on. The x-intercept is where y is 0. If I just say 0 equals all that, let's see if we can solve it. 0 equals, and the m canceled the other m, and I have negative 1 over m. And then I have minus 2 over m plus 3. Well, if you can factor it, you should. And there's no factoring that I can do there. That just came from the blue highlighted area, simplified, by the way. But there's definitely something else I could do. My number one rule is if you can factor it, you should. What's my second rule? If you don't know, you should know, because it helps clear fractions. Can I multiply by something to clear this fraction? Yeah, multiply by m. And it works really nice because 0 times m is just a 0. I times this by m and the m goes away on the bottom. This by m and the m goes away on the bottom. And this by m. And now I just have one little m left and I can solve for it. And it's not that hard. That make sense to you? Okay, so if I set for my x-intercept y equal to 0 right here, that's what just made all that happen. And last but not least, the y-intercept, and that's super easy. The y-intercept is just sitting right there, because if x is 0, the beginning part cancels out, and I just have y equals 3 was the y-intercept. Okay, I know that one got really intense. The rest of the time I want to save for you to work on the practice problems and the key. The only questions I want you to ask me today are questions that are from that practice set, and after you've looked at the key, if you don't get it, bring them up and ask me. Okay, I don't want you to dredge up old homework problems that were super weird and hard. Those will just waste yours and my time. But the review questions today, to work on all of those during class and ask me any of the questions that you want. And that's all I have for you for today. And now